This video is going to show you the solution to an example problem about adding vectors by components. So the question is, using the method of components, add up the following vectors. So I have three vectors on the screen, all with a common tail. And the trick is, when you use the angles that are shown, don't use any complementary angles. So it's a bit of a challenge to use the angles that's shown. That's kind of the point of this. So let me get a little more room, move it to the middle of the screen. First thing I'm going to do is I'm going to break up the vectors into components, horizontal and vertical components, so I can make right triangles. So I'll go over and up. Remember, when making components, you're making two vectors that add up to give you the one that's on the page. So when they add up, they have to touch tip to tail. So they all start at the same tail, and they move out and touch tip to tail, and they end up at the same tip at the top. So those are components, and that's important to get it right. Now I use trig to define the directions of the components. So I've got R, and I labeled it 5x since it was 5 newtons. So R 5x is equal to 5 newtons times cosine 72, cosine, because it's adjacent to the angle. The other one is going to be the other side. In the y direction, 5 newtons times sine 72. Now I'll continue this process and draw components around the angles that are given. So here's the next one, touching tip to tail, drawn around the angle that's given. And then I'll define it in the y direction as 3n cosine 58. In the x direction, 3n sine 58. Notice that if you look at these two vectors in the x direction, one uses the cosine function and one uses the sine function. Don't get stuck in the trap of always using one function or another for the horizontal or the vertical. Just apply the trig concepts, and it works every time. Next step, going around the angle again, and with components, horizontal and vertical, and I get 4 newtons cosine 81, 4 newtons sine 81. So there I have it. All the components already described out as I need them. Next, I've got to add up everything by components. So what I'm going to do is try to clean this up a little bit and get rid of the x components so I can just see the blue y components in this case. So as I do this, I'm going to first look at ry. So adding up all the components in the y direction, everything going up minus everything going down. So going up first, I've got the 5 newtons sine 72, plus what's also going up is the 3 newtons cosine 58. Now the 4 newtons sine 81 degrees is going down, so I'm going to subtract that one. Do a little bit of math, and I get in the y direction 4.69 newtons. Now because the answer is positive, and I know that everything going up is positive, I know that my answer for the y component is going to go upwards in the positive direction. On the calculator it would look something like this. So here's the calculator. What I would type in is everything is one long line, and then press the enter button to get the final answer with all the decimal places. And as a nice shortcut, what I would also do is take this value, since it's in the y direction for the answer, I'm going to store it. So I'm going to press the stow button on the calculator, and then I'm going to store it in the letter y. So I'll press alpha on the calculator to get access to the green functions, and the letter y, which is right above the number 1. Now my screen will look like this: answer, arrow, and y. So it's taking that value of 4.68 and storing it in the y memory cell. And that I'm going to use later. Alright, so let's kind of continue on this process. Let's look in the x direction. So I've seen what's in the y direction. Now let's look at the x direction. And I'll clean up my diagram a little bit further and get rid of a bunch of the y's and some other things. Now I can see all my x vectors. And so the answer in the x direction, if I look at it this way, everything going to the right minus everything going left. Just like in math class, right being positive, left being negative. So going to the right, I've got 5n cosine 72 minus 3n sine 58. And going left, I've got the 4n cosine 81, so I'll subtract that as well. So I'm adding all up, but the ones going left are negative. That's why I subtracted them instead. So I'll do a little bit of math, get my final answer of negative 1.62. And according to my convention, I said, like in math class, everything going left is negative. So that means my arrow for my answer is going to be going to the left. On the calculator, I would have typed it in. It's all one line like that on the calculator screen, and that would give me negative 1.62. Make sure you're in the degree mode since we're using trig. And I would also store this just like I did before, but I'm going to store it in the x memory cell because y is vertical and x is horizontal typically in a math class, so I'm going to stick with that. Alright, so now I've got this. I've got one more step. I've got to construct my final answer. So I'm going to get rid of a lot of the stuff you see on the screen and move the main drawing out of the way. And then I'll have in the y direction, ry, that is the resultant y component of 4.69. And then I got to make it touch tip to tail for Rx. Remember, when you're adding up two vectors to get the answer, they've got to touch tip to tail. And I get negative 1.62. The negative means going to the left. And the pluses and minuses are just direction indicators, and this direction indicator says left, so I'm not going to use it anymore. Now I'm just going to replace that with 1.62 because my diagram tells me it goes to the left. Next step, draw the answer. That's it. That's the resultant. When I add up those three forces, that vector is going to be the resultant. Now I haven't scaled everything quite right, but you get the basic idea. So I'm looking for the magnitude and direction, that is r and theta, for that resultant. So to find the magnitude, I'll use Pythagorean's theorem, as shown on the screen. And to find the direction, I'm going to use trig. So I'm going to use the tangent function of opposite over adjacent in order to find the angle. And I use actually the arctan, or the inverse tan, to get 19.06 degrees. Now, one of the things I asked you to do is also take all this and relate it to polar coordinates. So pointing due east is 0 degrees. So if I'm going to do that, it means I've got to go up 90 degrees and then add 19.06 to get 109.6 degrees. You could have also written it in kind of directional coordinates using 19.06 degrees west of pointing due north. If you're wondering what the calculator is going to look like, remember I stored those values before? So now I can take the square root of the value of y divided by x. Because they're stored in the memory registers or memory cells, the calculator just replaces the y and the x with those numbers and keeps all the decimal points. So the math is easy. And then to use Pythagorean's theorem, to find the direction in this case, take the inverse tangent of rise over run, so that's y over x, and again, it's got all the decimal places, so the math becomes a whole lot easier. Finally, the paper. What does it look like when you're all done? This is what it looks like on your piece of paper. It takes up almost a full sheet of paper. You can see there's a lot of blank space to make it easy to read. The vector diagram is very big. You're not trying to draw something for the next US postage stamp. Draw something big so you can label it. It's organized in columns, and above each piece of the math is something describing what you're trying to do with the math. And finally, just like always, equations have numbers and units.